Hello guys, welcome to Engineer's Palette. I hope you all will be doing well. So today our topic is Spline tool. We have three options in the Spline in Solidworks 2022. The first one is Spline, the other one is Style Spline, and Equation Driven Curve. We'll be covering all of them. Now for the first, create a basic spline. Select any number of points that you want to create and hit escape when you are finished. You can create different cool shapes, different types of shapes with a spline, like closed shapes or open shapes or whatever type you want. You can create with a spline. Now clicking on the spline, this handle appears. Now what is the meaning of this handle? It has three different points. The first one is circular, triangular, and the diamond one. Now let's check them, that what is the meaning of that. Now when you select the diamond, it only change the angle of the, like you can't change it actually, but you can only change the angle of the spline by this. Okay, now the other one is triangular, but with the triangular you can change the length of the spline. And there is another option which is a circular option. You can now change both the angle and the radius of spline. Now this was about the spline tool, that about understanding the spline, that how can you change its geometry. Now right clicking on this, there is a lot of options. You can play with the spline. You can add many things, like you can add more spline points, or remove spline points, or tangency control, or any of many points from here. You can play with it. The spline tool has some limitations, that you cannot define it by adding some like this dimensions like this, because you can create many different shapes, irregular shapes with spline, but you cannot define it. But for this purpose, what you do, you override this spline with the arc tool. Just what you do, make it for a construction. Here's now geometric line, and now select this one, 3-point arc, this point, or you can select any other point which matches your geometry, like that. And then from here to here, for example, yeah, here to here, like that. And now from here to here, like that. From here to here, like this one. And now from here to here, like this one. Now you can define it. You can define it by giving this radius of this, radius of that, radius of any point, and this is the point you need to understand. Now the second one is the style spline. What is meant by a style spline? That these geometric lines appears. I hate this. Now you can definitely change the style of the spline, or the geometry of the spline, by moving this, or by moving the line from here. You can now change it like that. You control actually by this. Now the style spline give you more comfort with the shape of the spline. The shape of the, because whenever you want to create some geometry, you will have a better option of a style spline, because when you create something by just a basic spline, it sometimes give you an awkward shape, like that, an awkward shape. But when you use this one, it always give you some good shape, a regular shape. So the style spline is a better option for creating a spline or for creating any geometry. Sorry. Now the third one is a equation driven curve. Now for equation driven curve you have two options. The one is explicit and the other one is a parametric. Now we will learn both of them, but let's understand how they work. You have seen many mathematical equations in which you give an equation, like you might have graphed these equations on some graph paper to see their response, like for example a sinusoidal wave. So basically if you have any equation and you put that equation here and define the x value, that how long you want to put that y, like for example y equals to some value, some function, and the function depends on the value of the x, dependent and independent variable. For example, the y is dependent variable which depends on the value of x, so you give x and it plots you a graph. Now for example, I have a sine x, simple sine function, and you need to move from 0 x equal to 0 to x equal to 12. Here is your automatically generated curve. You can add modify your equation. For example, if I'm giving 5 multiplied by sine of x, it will just increase the size of this. But you can also add something else to this. For example, 1.5 plus 5 times sine of x. Now you can see what it will give to you, this kind of equation. But you can also modify it further. If 1.5 times x, or for example make it 3.5 times x. Now look at the curve. This is your curve. Now the explicit equation means that you have some function, a dependent variable that is y and independent variable that is x, that you give a value to and create cool shapes. Now we'll see to the next the other type of equation, which is a parametric. Parametric means that you define some equation at some point, at some time. For example, you give a value of, for example, t, xt is equal to t, and y is the same equation. I would use like 1.5 times x plus 2x. Make it, let's just keep it simple for early. Okay, 2 times sine of x. Now t1 for the first time, where I have gone wrong. Yeah, I think here. Mm, 2 times x sine of, yeah, here. Oh, sorry, I need to give it a value of t, yeah, like that was. Yeah, no, it's good. Okay, now you will give a value, for example, from time 0 to time 10, for example. Here is your curve. Now for example, you change the value of x of t, and or for example 2t multiplied by t, and hit yeah, that's a 3t, by the way. Sorry. Now you can change the equation to, like, for example, I'm giving it 10 t plus 10. There is your equation, that curve that has changed. Now give it, for example, 2 times t, like this. You can play with it. You can give different types of equations here and create different types of cool shapes. So this was all about a spline tool, and I hope you would like that. Please like and share with your friends and subscribe to our channel. I will see you in the next video. Take care.